Today we are going to talk about one of the block cipher modes of operation. Cipher Feedback Mode, as known as CFB. In this video, I will cover about block cipher, modes of operation, Cipher Feedback Mode encryption and decryption, also pros and cons of Cipher Feedback Mode. Now let's get started with introduction of block cipher. What is block cipher? A block cipher is an encryption method that applies a deterministic algorithm along with a symmetric key to encrypt a block of text, rather than encrypting one bit at a time as in stream ciphers. Block ciphers are pseudorandom permutation families that operate on the fixed-size block of bits. PRPS are functions that cannot be differentiated from completely random permutations and thus, are considered reliable, until proven unreliable. Here are two common block cipher schemes which are Digital Encryption Standard, DES, and Advanced Encryption Standard, AES. Now let us look into what is modes of operation. Block cipher modes of operation have been developed to eliminate the chance of encrypting identical blocks of text the same way. The cipher text formed from the previous encrypted block is applied to the next block. A block of bits called an initialization vector is also used by modes of operation to ensure cipher texts remain distinct, even when the same plaintext message is encrypted a number of times. Here are some various modes of operations. This video we will only focus on Cipher Feedback Mode, as known as CFB or CFM. Cipher Feedback Mode encryption. Before we start with the operation, we need to define some important value. First, is the size of initialization vector. In this video I will refer as n bits. Second value is size of plaintext block, I will refer as s bits. Plaintext block sizes also affect how many cycle repeated of the CFB process later. Keep in mind, the n value must larger than s value. And the size both value are normally multiple of 8 bits. Now, both values are ready, we can proceed with the CFB process. In the CFB process, first we have n bits of initialization vector, IV. I labeled it as x0. Then we pass the IV into a block cipher encryption and encrypt with a key 0. Now we have an encrypted IV with n bits. Next we select the first s bits from the encrypted IV for next step. The rest we can discard it. Finally we use the first s bits of encrypted IV and perform a XOR operation with s bits of plaintext, P0. Now we get s bits of ciphertext C0. This is also one cycle of CFB. Now here come the second cycle, this is the most important step in CFB. For the second cycle, we discard first s bits from the previous x value which is x0 in this case. Then perform the left shift. Now we have only n-s bits which is not enough for the operation. So, we concatenate with the ciphertext produced from previous cycle. Now we have n bits of shift register to perform the following step. The following steps are exactly same with the previous cycle. The cycle continue until all plaintext blocks are encrypted. I know it is still hard to understand, no worry, let me explain again with an example. Here is the example. I will define the size of initialization vector as 128 bits, and size of plaintext block as 64 bits. In this example, I use 320 bits length of plaintext. First we need to divide our plaintext into blocks. We divide 320 bits with 64 bits, we will getting a 5 blocks of 64 bits block. I labeled it as P0 until P4. Now we proceed with the CFB operation. First we have 128 bits of IV. We pass the IV to encryption process with key 0. And get the encrypted IV. Then we select the first 64 bits from the encrypted IV for the next process, we can discard the rest. Next we perform XOR process with first block of plaintext P0. Now we getting our first block of ciphertext C0. We continue with the second cycle. We discard the first 64 bits from the previous IV. And concatenate with the ciphertext generated in previous cycle. To form the new shift register. Next we perform the same process with key 1. And second block of plaintext P1. And produce the second block of ciphertext C1. The process continue until P4. Now we have 5 blocks of ciphertext. The only thing we need to do is concatenate the ciphertext block to get the ciphertext. Here is some notes for encryption. We cannot perform the cycles in parallel due to the shift register keep changing according to the ciphertext block from previous cycle. Secondly, we can use the same key for the block cipher encryption, unlike others modes of operation. Since the shift register will always discard and add some bits, we will getting a different encrypted IV space for every cycle even the keys are the same. Next we will talk about decryption of CFB. Cipher Feedback Mode decryption. Before decryption, we definitely need a ciphertext, initialization vector, size of IV and size of plaintext. In this case, we must use the same value as encryption. We must break down the ciphertext into blocks too. Divide the ciphertext into 5 blocks of 64 bits block. I labeled as C0 to C4. Now we proceed with the decryption process. For decryption of CFB is very simple. The decryption is just the opposite direction of encryption process. First we also encrypt the IV with key 0. Then use the first 64 bits of encrypted IV to perform XOR operation with first block of ciphertext C0. Now we can get the first block of plaintext P0. Same goes to second cycle. Discard the first 64 bits of previous IV and concatenate with the ciphertext P0. The rest are performed the same process. The cycle continue until all block of ciphertext be decrypted. Same as the encryption. We concatenate all the plaintext box to get the final plaintext. Even the decryption process are similar to encryption, the notes for decryption are different. First, decryption can perform in parallel since we already know all the ciphertext, so we can also know the shift register for each cycle. Secondly, the key must use the same key as encryption, this sound logic. You can't unlock the door with a different key that locked the door. Lastly, I listed down some of the advantage and disadvantage of Cipher Feedback Mode. For the advantages, we can encrypt it with the same key which I explained in previous slides. Besides, we can also avoid padding since the last block of the plaintext is not necessary to be exact size of S bits. We can also encrypting with a small block of data. This will make the encryption process faster. The disadvantages are CFB are less efficient compared to CBC or ECB, and the pattern at the block level are not preserved. These are all of the content I shared today. Thanks for your watching. Hope you can understand more about Cipher Feedback Mode.